So here we are. We have a square piece of cardboard, 8 by 8. And I know you've seen this kind of problem in pre-calculus. So you're going to cut out corners, and the corners are going to be squares. There's squares in the corners. Okay, so that means this is x by x, right? X by x. So all these are just little squares that you're cutting out so that you can fold these things up. Okay, so this is the constraint. They're giving it to us in a different way. We're not going to make an equation out of it, but what are we trying to find? We're trying to find the largest volume. So again, in your head, you're thinking, I need to set the derivative of the volume equal to 0. So let's find the volume equation. So that's going to be length, right? So length times width. I think those are going to be the same distances, right? So if this is x, if this is x and this is x, won't this yellow length here be 8 minus 2x? 8 minus 2x? Hey, wait a minute. Isn't that going to be the same thing here? 8 minus 2x. Okay, so that's length times width, right? Length times width. And then how do we find the height? The height is going to be this side length of x that we're folding up. Okay, so let's just rewrite what this is. We have 8 minus 2x squared x. So sometimes your constraint doesn't come in another equation, but it just comes from the, information given. I want to take the derivative of this. I'm going to suggest we not multiply it out. Let's just do it by doing product rule. So if I do the derivative, so first, d second, which would be 1, plus second, d first. Got to do chain rule, right? 8 minus 2x to the 1 power times negative 2. Oops, negative 2. I wrote negative 2x, and I did not need to. Get my eraser going. Here we go. Negative 2. Okay, so now, I'm just going to play with this a little bit. I really don't like multiplying everything out, so I'm just going to write this again. These things here make a negative 4x and then an 8 minus 2x. Do you see there's an 8 minus 2x in common between this term and this term? Yes. So let's factor that out. So if I factor out an 8 minus 2x out of this term, I'm left with an 8 minus 2x. If I factor an 8 minus 2x out of that term, I'm left with a minus 4x. Okay, so I've got two things multiplied to equal 0, right? This times this equals 0. So that means 8 minus 2x is 0, or 8 minus 6x is 0. So this here gives me 2x is 8, x is equal to 4. And let's see what this one gives me. This gives me x is equal to 8 over 6, or 4/3. Okay, so let's see. Does either of these get eliminated because it doesn't make sense? So let's look at 4/3. If this is a whole side length of 8, is it okay if I turn up little side lengths of 4/3? Sure, that works. How about this one? Can I turn up side lengths of 4 if I've got the whole thing is 8? No, because there would be no box, right? Be completely flattened. So this answer gets eliminated, and this is the only value of x that I can turn up the sides. So what are the dimensions of the box? So the x would be 4/3, and then the length and width, so let's say L and W will be 8 minus 2 4/3, right? 8 minus 2, the two x's. So that would be the other dimension.